Hey guys, so in this video we are going to cover the CVS embryology and anatomy. So from the development of heart to how the internal anatomy and blood supply of the heart, we are going to learn all of this in one video. So let's go. So first about the development. So first the location of development of heart. We know that during the germ layer development, we know that there are mainly three layers: ectoderm, mesoderm and endoderm, and there will be development of primitive streak on the ectoderm, and that will form the mainly gastrulation. Initially there was hypoderm and epiderm. So in epiderm there will be development of primitive streak, and this will form all this three layer. So in epiderm only, from epiderm only this three layer is going to be formed: endoderm, ectoderm and mesoderm. So this ectoderm part, there will be still this primitive streak and primitive knot, and there will be cordocranial direction will be formed by formation of this cloacal membrane and trochoidal plate. So cloacal membrane, we know it will form the anal part, and the trochoidal plate will form the the cranial part. Now this trochoidal plate and septum transversum, in between this there will be cardiogenic area, and this cardiogenic area will be useful in the development of heart. This will develop this heart. So first there will be two endothelial heart tubes, and this will fuse. So let's see by drawing a diagram. So initially there will be two endodermal heart tubes, endothelial, and this will fuse like this. So beginning of fusion of heart will form by this end. So heart tube will form. Now this heart tube will form at 22 days. So at 22 days this heart tube will form, and we can divide this heart tube into mainly this part. So truncus arteriosus, bulbus cordis, primitive ventricle, primitive atrium and sinus venosus. So from your typically heart, remember that the direction will be totally opposite. So this atrium will be on downside and ventricle will be on upside, because what will happen after that, this downward part is going to come upwards. So it will be totally opposite from our outflow track. So you can remember from downward also that sinus venosus, primitive atrium, primitive ventricle, and then bulbus cordis, and then truncus arteriosus. Now as you can see here also, so 23 days, 24 days and 35 days. At 35 days our heart will look like this, and at 50 days the normal anatomy as we see in the newborn will be formed. So 23, 24 and 35 days. If you want to remember, you can remember, but not very important. So as you can see, sinus venosus, atrium, ventricle, bulbus cordis and truncus arteriosus. After this, sinus venosus, atrium, ventricle, bulbal cordis and truncus arteriosus. But what will happen, this will be shifting like this. So after one point, what will happen, this atrium and sinus venosus part both will come upward. So as you can see here, that this right atrium will be here, left atrium will be here, and this ventricle part will be downwards, and this aortic arch arteries and truncus arteriosus will be up only. So this will be like this. Now the structures which are developing is what we have to learn. So first about the sinus venosus. So sinus venosus will form I am going to write here only. Let's start from the upwards first. So first about the truncus arteriosus. Aorta and main pulmonary artery, both are going to arise from this only, truncus arteriosus. Second, from the conus part and bulbus part. We know that bulbus cordis will be divided into these two parts. So conus part will form the outflow tract, and it will be smooth. So right ventricle outflow tract and left ventricle outflow tract. Now about the bulbous part. Bulbous part will form the right trabecular part, about the right ventricle trabecular part, and from primitive ventricle, this left ventricle trabeculated part will arise. Now from the primitive ventricle, both right atrium and left atrium trabecular part will arise. From the sinus venosus. So this will be slightly tricky, I guess, this part. That the sinus venosus has two horns. So right horn and left horn plus one body. So this body plus right horn, these two together will form the right atrium smooth part. So right atrium smooth part. This is also known as sinus venerum. Now this left horn will form coronary sinus. Now there is some vein. So primitive pulmonary vein and common cardinal vein. So this primitive pulmonary vein will form the left atrium smooth part. Remember, it is a vein which is forming the left atrium. Normally what will happen, from the left atrium there will be pulmonary artery which is arising, but this primitive pulmonary vein is going to form the from left atrium, yes, pulmonary vein is going to come and drain into this. Okay, I have confused this with left atrium, left ventricle. So this primitive pulmonary vein is going to form the left atrium smooth part. There is this common cardinal vein will form superior vena cava, anterior cardinal vein. Major identifiable pairs of vein. So vitelline vein, umbilical vein and common cardinal vein. So this vitelline vein will receive blood from yolk sac. This umbilical vein will receive blood from the placenta, and this common cardinal vein receive blood from the body wall. But only this vitelline vein and cardinal vein will give contribution to the formation of inferior vena cava. So this is the development of inferior vena cava. This is the superior vena cava part, and this was about the development we have to learn about the two development of structure. So first is interventricular septum and second one is fossa ovalis. So let's see. So the interventricular septum this is first, so this is spiral septum which is derived from the neural crest cell. as you can see here. This is the articopulmonary septum, which is a spiral septum in the sinus venosum. Now what will happen if it is anteriorly displaced? There will be TOF, that is tetralogy of Fallot. If it is absent, then there will be persistent truncus arteriosus. And if it is non-spiral, then TGA, means transposition of great arteries, will happen. Now about the development of fossa ovalis. So as you can see here, first there will be septum primum in between two ventricles, right ventricle and left ventricle. Now this septum primum will come here like this. So what will happen? There will be no gap to flow of blood to go from right atrium to left atrium. So that's why there will be foramen secundum will be formed in between this septum primum. So first the foramen will be foramen primum here like this and septum primum. But when the septum primum will be like this and foramen primum will be closed, there will be formation of foramen secundum. Now there will be development of septum secundum, and this septum secundum will come here. So foramen ovale will be formed here. And after birth, what will happen? This foramen oval will closed. So two terms, fossa ovalis will be formed by septum primum and limbus fossa ovalis will be formed by septum secundum. At birth, what will happen? The left atrial pressure will be more than right atrial pressure, and this foramen oval will close. Now about the inner structure of the heart. So first let's see the right atrium. So in right atrium, as you can see, there will be two parts, smooth part and the rough part. So this is smooth part of right atrium. From here SVC is going to come, from here IVC is going to come, and IVC is gonna have this eustachian valve. So valve of inferior vena cava, here this one is eustachian valve. pre-eustachian, it is CH, eustachian valve, and there will be a coronary sinus, as you can see here. Orifice of coronary sinus is here, and there will be valve of coronary sinus. So we have to remember two things: inferior vena cava opening and valve of inferior vena cava, coronary sinus opening and valve of coronary sinus. So this valve of coronary sinus is known as Thebesian valve. Thebesian valve, and this coronary sinus is actually left horn derivative structure. So superior vena cava has no valve, IVC has eustachian valve, coronary sinus has Thebesian valve. These three things we have to remember about the openings in right atrium, and two parts, the smooth part and the rough part. This thing we have to remember about the right atrium. Now there is also crista terminalis. So this is crista terminalis. What is it? It is a lining between the smooth part and rough part. As you can see here, this smooth part and this rough part lining is crista terminalis. Here you can see this is fossa ovalis of right atrium. Sorry, this is fossa ovalis of right atrium. Let's see one important structure here. Okay, I have to place this somewhere else. So this is the triangle of Koch. As you can see here, the boundary is this. So inferior vena cava, coronary sinus and the septal tricuspid leaflet will form the boundary. So let's see the boundaries. This one, and here there will be tendon of Todaro at the apex of triangle. So this is his bundle, that is tendon of Todaro. This one, this. So this is septal leaflet, this is tendon of Todaro, and the third one is ostium of coronary sinus. So this is our boundary. Don't remember this actually. Sorry. Instead of this, remember tendon of Todaro. So 1, 2 and this 3. So this Koch triangle is actually a area where the AV node is present. And the upper part of cristae terminalis so somewhere here like this there will be SA node. So this two structure location we have to see in the right atrium. Crista terminalis is the junction between the smooth and rough part of the right atrium. So this is a smooth part, this is a rough part. In junction there will be crista terminalis, and upper part of crista terminalis is where the SA node will be located. Then in smooth part we have learned the three locations that are SA nodal opening, IVC opening and coronary sinus opening. IVC opening have this eustachian valve and coronary sinus opening will have Thebetian valve, and this coronary sinus opening plus septal leaflet of the tricuspid valve plus this his bundle branch location means tendon of Todaro will form the Koch triangle, and here there will be location of AV node. So as you can see, this AV node actually is located on the atrial septum, and posterior-inferior part will be there mostly. Now about the right ventricle. So right ventricle we have to remember three things mainly, that this muscles, so ridge, bridge and pillar. Ridge is supraventricular crest, bridge is moderator band, and the pillar is papillary muscle. So as you can see here, first let's see the papillary muscle. So this is the papillary muscle. Papillary muscles are three in the right, in the ventricle, and the location is inferior, superior This superior and inferior and the septal one. I don't know where they have mentioned this septal. And this is all coda tendini, so tendinous coda. Now about the blood supply.